Hey everyone, this video is going to be a refresher over factoring polynomials. We're going to factor the GCF, we're going to factor a trinomial, then we're going to factor sum and difference of cubes, and lastly we're going to factor by grouping. So we're going to do several different kinds of factoring in this video. So we're first going to begin, whenever we start any factoring problem, the first question we always ask is there a GCF that we can take out? And that stands for greatest common factor, meaning, is there something that I could divide into every single term in the polynomial? When I look at this example, I can see they clearly have a 2 in common. I could divide a 2 out of all of them. And I also realized that I could also take an x squared out of all of them. All of them have at least an x squared in them. So you want to take the largest common factor out of each term first, if possible. If it can't come out of all of them, then you skip this step. So if your GCF is 2x squared, you put your GCF in the beginning of the parentheses, and then you divide to see what's left. So for my first term, 2x to the 4th divided by 2x squared, I'm left with just x squared. If I divide my second 2, I've got negative 2x to the 3rd divided by 2x squared, which just leaves me with an x. And 4x squared divided by 2x leaves me with just a 2. My x squareds cancel, and that divides to be 1. So now that I have taken out the GCF, I last need to see if what is left in the parentheses can be factored any further. So in order to do that, we have been using in class the X box. So we are looking to see if two numbers can multiply to a times c, which would be negative 2, and add to the b, which is negative 1. So what multiplies up to negative 2? Well, I've got 1 times 2. 1 times negative 2, or negative 1 times positive 2? Well, 1 and negative 2 will add to negative 1, so I can factor this. This is going to be x plus 1 and x minus 2. Bring this down, my GCF. Now I have factored this as far as I can. So just make sure you factor it as much as you can, and then you're done. All right, let's try another example of factoring. All right, this problem, the first thing, as always, that I told you that we're going to always ask is there a GCF? Well, in this problem, there is nothing I can take. They do not have an x in common, and they don't have a number in common. So we have to find the next thing we can do to factor it. What I notice about this problem is, first of all, this one is a cube. It's to the 3rd power. And this one I could rewrite as a cube because I know that 27 is the same as 3 to the 3rd power. So since I can write both of these in terms of to the 3rd power or cubed, then that means I also notice that I have a minus there. That means I can use the difference of cube formula. Anytime I have two cubes that are being subtracted from each other, I can use this formula. And this formula will be given to you on your formula chart, but you need to know how to use it. So the formula that is given to you is, it tells you to subtract a minus b, a squared plus a times b plus b squared. So in order to use this formula, we first need to know what a and b is. After we have rewritten our cubes into cube form, meaning they both have an exponent of 3, we can see that our a, the base here, is going to be x, and our b is going to be 3. So that is what we are going to plug into the formula. We're going to plug in x for a and 3 for b. So let's plug it carefully into our formula. So I'm going to start at the beginning. In place of a, I'm going to put the x, bring down my minus sign. In place of b, I'm going to put the 3. The next part of the formula says a squared. Well, my a is x, so I'm going to plug in x squared plus a times b, so x times 3 is 3x plus b squared. Well, 3 squared is 9, so I can go ahead and simplify that to be 9. And that's it for difference of cubes. I have now factored that polynomial. All right, let's try sum of cubes. This problem is very similar to it because I can rewrite both of these in cube form, because I can write 8 as 2 cubed. Look at what I did, not 2 squared. 2 cubed. 2 times 2 times 2 is 8. X cubed plus 125 is the same as 5 cubed. I already checked to make sure I couldn't take out a GCF, and since I can write them both in terms of, I can put them both in cube form, and I have a plus sign, that means this is the sum of cubes formula that I will be using, which tells me if I can write it in a cubed plus b cubed, the formula I should use is a plus b. It's a very similar formula, just different signs. Plus b squared. So this is the formula I will use when there is the sum of cubes. So first I want to identify what my a and b is. The base here, a is going to be 2x. It's going to be my base. My b is going to be the second base, which is 5. All right, so now let's begin by plugging into the formula. First, I'm going to plug in my a, which is 2x. My b is 5. Next, it says to plug in a squared. Be careful, because 2x squared means that I have to square both of these. So 2 squared is 4, and then x squared. Sorry, that's the bell, but we don't get to end. We're not done with the problem yet. So 4 squared. Don't forget to square the 2, because that's a common mistake that a lot of students miss. Minus, next part says to multiply a times b. So I'm going to multiply 2x times 5. 2x times 5 is 10x. Last part is b squared. So 5 squared is 25. So very similar to difference of cubes. Sum of cubes just has a slightly different formula. All right, this is the last kind of factoring that we're going to practice today, and it is called grouping. And the first thing we still look for is there a greatest common factor that can go into all of these terms? Well, in this case, there's not. There's nothing. It almost looks like 8 could go into it, because 8 can go into this one, 8 can go into this one, and 8 can go into this one, but 8 can't go into 1. So we can't do that. The x's goes in this one, and this one, but there's no x here. So we don't have a greatest common factor for all 4 terms, but we always want to check that first. Next, if you end up and you have 4 terms, grouping is a really good strategy for factoring, because you can take the GCF out of 2 terms and then out of 2 terms and regroup them. So let's look at the first 2 terms. Just the first 2 terms, I can take out an 8 as a GCF. They both have an 8 in common. And I can take out an x squared, because they both have that in common. So I'm going to scoot it down so I can show you what it looks like to divide it. So 8x squared, and I'm going to divide by 8x squared. All right, so 8x cubed divided by 8x squared, and I'm just left with 1x. Bring down my minus sign. 64x squared divided by 8x squared. 64 divided by 8 is 8, and my x squareds are going to cancel, so I'm just left with x minus 8. All right, let's look at the second group. Now, there's nothing I can really take out of an x and a minus 8. Your sign here is always going to come down. And since I can't take anything out and I must take something out in order to make it group, I'm just going to put a 1 there and bring down my x minus 8. Now, in order for grouping to work, your factors must be the same, and your x minus 8 and your x minus 8 have to match, because you're really going to take a GCF out of these two terms. And you notice they both have an x minus 8 in common. So we're going to take out the x minus 8 that's in parentheses, and we're going to put together what is on the outside, 8x squared and the plus 1. So that is how you factor by grouping. Let's do one last factoring problem for good measure. So for the first two, first I'm going to look at this whole problem and see if I can take out a GCF. Well, let's see. I don't see anything that can go into all of them. So let's start by grouping. If I look at the first two terms, looks like the biggest number that would go into both of them would just be a 2. It feels like something bigger, but it doesn't look like that. And I could take an x squared out of both of them. So now let's divide. 6x cubed divided by 2x squared is going to leave me with a 3x. Bring down my minus sign. 16x squared divided by 2x squared, and that's going to leave me with an 8. My x squareds cancel. All right, bring down my plus sign. And now I'm going to look and see what I can take out of these two terms. Well, looks like I could take a 7 out, because I know 7 times 8 is 56 and 7 times 3 is 21. So let's take out a 7. Can't take out any x's because this one doesn't have any x's. So 21x divided by 7 leaves me with a 3x. And negative 56 divided by 7 leaves me with a minus 8. Now, again, you notice what is left in parentheses are the same. And that was the goal for factoring by grouping. So I can take what is on the outside of the parentheses and put them together. That will be 2x squared plus 7. And I can put it with what is on the inside of the parentheses, which is 3x minus 8. So that is how you factor by grouping. Factoring, again, is one of those skills that takes a lot of practice, so make sure you practice tons and tons and tons of factoring problems until you feel like you've got it and you are ready. Factoring is something that we use all year in algebra, and you'll use it next year in whatever math you use as well. So it's super important to keep practicing it. Good luck.